So our number 97, which is basically taking a verbal expression and turning it into an algebraic expression. Now it says the total hourly wage. So this is the wage per hour that you get. Okay, that's going to equal $8.25 per hour. So you automatically have $8.25 every hour that you work. Okay, plus an additional 60 cents is paid for each unit that you produce. So you automatically have $8.25, that's a constant, right? That's what we call a constant, something that's already there, not affected by a variable. But what is affected by a variable is going to be the amount of the money that you get per unit, which is the variable. So for example, here you have $0.60 for every unit that you produce. Okay. So in this case, this is the coefficient, and then here you have your variable. All right. So you have to be able to turn verbal models into algebraic equations, basically, or algebraic expressions. Here it's an equation because we have the equal sign going into. Okay. So unit's going to be your variable. It is going to determine how much more money you get, right? So a person who works, let's say, who works for an hour and produces 2 units only, they're just going to get $1.20 extra, but they're going to make sure they're always getting this $8.25. And then a person who maybe in an hour produces 100 units, they're going to go get an extra $60 in addition to the $8.25. Okay, so be able to do that. Be able to turn verbal models into algebraic expressions. All right, and then translate the phrase into an algebraic expression. Same thing that we've been doing. Okay, let's just go through number 101. Same idea. Okay, just sentences instead of all of these paragraphs. Number 101 says 10 less than twice a number. This phrase, a number is just going to be a variable. So you can use x, you can use n, you can use s, you can use t, you can use p, whatever you want. A number is just going to be a variable. So 10 less, that's going to be minus, then twice a number. But now this less than, that's going to be comparative to the number. So that x is going to come first, 10 less than twice a number. That twice is going to mean 2 times whatever variable that you put. So 2x minus 10. That's going to be the verbal model for that. Okay? So 101, 2x minus 10. All right, so be able to do that, be able to convert more verbal models into algebraic expressions. And then that's pretty much it. You also have to do number 113, which is the same idea as number 97, and just be able to do those operations. And then remember that percentages have to do with decimals, so 5% is going to be 0.05. Okay, and then section 2.4. This is basically the easiest section here, and that's the bell. So for section 2.4, same exact thing that we did before in section 2.2, except now you're checking whether a given value is a solution to equation. You're going to have to plug in the values into the equation and then tell me if it is right or if it is wrong. So you would just write yes or no, and that's pretty much it.